So let's go ahead and solve some of these, just see what happens. Give you some examples. So v divided by 8 is bigger or greater than 0. What number divided by 8 is bigger than 0? We can solve this. It's multiplying by 8 on both sides, right? So it's divided by 8, so you undo dividing by multiplying. Gotta do it to both sides. All right, so we have 8's canceling, and we just have v is bigger than 0 times 8, which is still 0. And we can solve the next one just the same. It's a plus addition, so we're going to subtract both sides. We have v is less than or equal to what, negative 10? And it's the word or. So that means the answers could be one way or another way. When we had the word and, that's when it's really restrictive, and the answers have to fulfill both of our inequalities. Okay. So, nothing really weird about this. Okay, 1 at 0 going this direction. Negative 10. Notice how this one's a solid. And it's going less than, it's going the other direction. Nothing too usual about that. Just standard problem. Same idea number 2 though. X divided by 3, so undo by multiplying by 3, both sides. Now this has the word and. That changes the meaning. Okay. Add 4 to both sides. So we have x is less than 4. Less than negative 0, and then greater than 5. But it's the word and. What does the word and mean in this? Okay, you're trying to find the numbers where what numbers are both of these true? It can't just be or, like one or the other. Okay, so what numbers are these both true for? Okay. If you try to graph it, if we're trying to make sure both of them are true, you would expect to see some overlap. Okay. That would be the answer, is where they overlap. But as you can see, there's no overlap. Okay. So therefore, there's no solution. With and, it's when they both have the same answers. They overlap just a little bit or just some. Okay. Here's what I mean. Typically, you'd see x is less than 3 and x is greater than negative 2. If we graph this, you say, okay, x is less than 3. That would look like this. Alright, x is greater than negative 2. Okay, that would look like this. Alright, so the answer is right here. Right? From here to here, they overlap. So the answer would simply be just from negative 2 to 3. And that would be your final answer. It's when they're connected, right? But here, you don't have that overlap. So, no overlap, no solution. Okay. And that's only with the and. That's the restrictive one where you have to have both. So when you notice how when we had the or, we don't care about overlap. One's going one way, one's going the other, doesn't matter. Okay. So understanding the difference between the or and the and is crucial. We wish it could just be memorizing steps, but we do have to think what type of problem it is. What is the problem asking? Alright, let's go down here, go through a few more. Same idea, p divided by 8, multiply by 8, multiply by 8. So we're saying p must be bigger than or equal to negative 8. Or, alright, divide by negative 9, divide by negative 9. Little blast from the past, what happens when you divide by a negative?
Sign switch.
Okay, you gotta remember to switch the sign. Okay, so that inequality sign will switch to greater than or equal to because of dividing by a negative. And what do you get? Yeah, they're both the same. Okay, never thought about it, but yeah, I guess both of them come out to be the same thing. So what do? You just graph it. Right? And it's greater than. So even though this is an OR, you're expected to see one arrow going one way, one going the other. Doesn't on this problem. So again, these are all the special cases. Sometimes these weird things happen. You get the no solution. You get where both of them turn out to be the exact same thing. Just don't think that that's like, well, a sign of I messed up, there must be a mistake or something. It can happen. Just check your work just in case, though. Sometimes you get these things by mistake. Okay. Some more. We can try some more, right? Number 4, subtracting 2. Okay. Subtracting 5. Okay. Same thing. This time it's just less than. Alright, we can deal with that. Yep. Which one? Oh, that one's, the second one isn't. Alright, let me rewrite that. There we go. Very good, I. So, or. Okay. So, that'd be like the first one, right? Well, the first one would be have a solid dot going that way. This one doesn't have, but if you think about just drawing it right over, it still stays solid, right? So, yeah, we want to keep that solid dot. So your correct answer would be, just that. With or, if you had a choice between them, it's the one that includes more numbers. Let me give you a side problem to think about. If you want all the numbers that are bigger than 1 or bigger than, say, 3, what would that mean? Okay. So here's 1, here's 3. So the first one is saying, I want everything bigger than 1. This one is saying, I want everything bigger than or equal to 3. Okay. Well, here's the thing. This one includes all of these numbers. Everything bigger than 1 will include everything bigger than 3. So our final answer will just be everything bigger than 1. We wouldn't even have to put this in our final answer because it's included. If you say I want all the numbers bigger than 1 or they're bigger than 3, it's redundant. You're saying the same thing twice. It's kind of like you're saying, okay, you want 1, you want 2, you want 3. Okay, but this one's saying you want 3. This one says, 4 is okay. This one's saying you want 4. So you don't need to, say the same thing twice. I want everything bigger than 1 or bigger than 3, because this one is really just saying everything that's included within this one. So your final answer, like if this was like a Khan Academy, final answer would be just x is greater than 1. So again, another weird situation where, you have two inequalities, you might solve it and get two different inequalities, but the answer is just one of them because they're pointing in the same direction. We're so used to the ORs going opposite directions. And let's see. Anybody want to take a guess on number 5? remember? What? It's what? No solution. Good. Why? Yeah, so this is saying what numbers are more than negative 18 away from something. You can't be more than negative 18 away from anything. That's impossible. So the idea that you have absolute value, okay, and then a negative, okay, doesn't make any sense because this number over here is distance. It stands for a distance. Okay? And you can't measure anything that's negative 2 feet. You can't drive negative 18 miles. It's impossible. Okay, so keep in mind it's when you have only absolute value on the left. So here, if I change this problem just a little bit, watch this. If I go back, I change this to put a negative 2 in front. Now does it have a solution? Yes, because the first step would be to divide by negative 2, right? And now we would have this, less than positive 9. So I don't want you just to look at the right-hand side and say, okay, negative, no solution. Not necessarily. Only when you have absolute value on the left, nothing else. And then on the right-hand side, it's negative. It's one of those things you want to get excited about every time you see that negative. So that's good. But then check to see, well, is there a negative on the other side that will make it a positive? Check that first before saying no solution. But yeah, no solution. Good. All right. So no solution? Is that what I'm getting? I'm thinking about this for a second. Take out the one I wrote down. I might have to take that back. Let me think about it. Because this isn't equals, right? It can't equal a negative. Can it be bigger than a negative, though? Yeah. Changing my mind, I think. So what numbers can we plug in here, take the absolute value, and get a number bigger than negative 18? Think about that for a second. When you plug in a number in here, is it bigger than negative 18? Yeah, I think you're right. It's always going to be bigger than negative 18, right? No matter what number I pick, if I plug in negative 2, simplify it in there, I'll get 8 minus 6, absolute value. That's bigger than negative 18. I could put in negative 100. I could put positive 100, right? Negative 400 minus 6, negative 406. But absolute value of negative 406 is still bigger than negative 18. So now I'm switching my mind. It seems like since this is greater than, it seems like all numbers work. Okay? Because this right here is always positive. No matter what number I plug in here, it's going to come out positive. Therefore, it's always going to be bigger than negative 18, no matter what. So what we were thinking about, when I was thinking about for a second, is when is it, if this was equal to negative 18, that's impossible, because we can't get a negative inside from an absolute value on the left-hand side. But for it to be bigger than negative 18, yeah, it's always bigger than negative 18. So the sign matters. The interpretation changes depending on the sign. So these special cases, as you saw me, even when I was looking at it, I had to give a second look at it. Like, it really requires some critical thinking of what things mean. So there's an example of an all real, and it's also an example of how much the meaning can change just with one symbol. Saying, when will this be exactly negative 18? That's impossible. When will it be bigger than negative 18? All the time. No matter what number I pick, it's going to be bigger than negative 18. It's always positive. Okay? So one little symbol can change the entire meaning of what you're working on. That's why we kind of save this for last. You want to get the mechanics down. Okay, add this to both sides, multiply to both sides, do all that. But then in the end, we do have some critical thinking to do to really think about what's going on. All right. Good. So I'll let you. Do we need to do some more? So let's go down right below it. 7. So notice how this 7 is divided by 7. It's not inside the absolute value. These bars do not go down all the way. So the first thing we want to do is multiply by that negative 7. I mean, the positive 7, sorry. So that equals 1. So this is kind of good. Similar to right above it. What's different, though? Yeah, now it's a less than. So how does that change? How does that change everything? So when will this absolute value be less than a negative 14? Never. Exactly. So this is the no solution. It's impossible for absolute value to be less than negative 14. So again, one little symbol changes everything. Greater than? Yeah, absolute value is always bigger than a negative. No solution. Equals? No, it's never going to equal a negative. Cool. Good. And then here's another no solution. Remember, and we're looking for an overlap. Okay, there's no numbers that are less than 0 and they're also bigger than 5. Those numbers never exist. Okay, so we can't have that. That's why there's no solution there. Okay, we might as well just finish the last two. What do we get here? Anything different or weird about this? There's no negatives here. So I think we're just going to go to our negative 10m plus 8 is less than 68. Negative 10m plus 8 is greater than negative 68. Okay, is that correct? Verify my work. Just notice how I just changed those. Okay. So it's less. The first one's less than positive. The second one's greater than negative. Switch to both sides. Okay, let's solve. 60. Is this a and or an or? And because less, yeah, remember think less than. Less than, think of a D on the end. Less than is an and. So we're looking for overlap. So do these overlap? Do the answers overlap? So here's negative 6. It's going to the right. There's the first one. And then 7.6, that's over here. That's going to the left. Yeah, so they overlap. Well, the final answer is just going to be, yeah, these are connected. They'll be connected from negative 6 to 7.6. You'd write your final answer, remember, like this. All the numbers between negative 6 and 7.6 is how you write your final answer. Because of the and, you have to have the special notation for your answer. So the overlap is between negative 6 and 7.6. And that's what I'm saying right here. My answer is between -6 and 7.6. So it's important to remember, as always, when we have these special cases, don't think that for every problem now is going to be like that. It doesn't happen very often. So most of your problems will be like what we have been doing this past week, and like you did last night on those. All right, so enough about that. I'll let you finish just that one on your own. It's similar to another problem. Actually, what do you think 8 is? Think about it. Which one is it? All real or no solution? So look at the other problems that are similar. Which one is this one more like? Okay. Ask yourself, what is this saying? Okay. Change the variable for some reason. Make a p. So if I add 4 to both sides, this will be -27. Okay. So which problem is this like? So like 7? It's like 5, right? Because it's a greater than. So you can think about, this is asking what numbers are bigger than a negative? What absolute value numbers are bigger than a negative? 27. All of them are. They're actually all going to be 0 or higher, right? So this is an all real numbers. All real numbers. So yeah, the one sign makes a big difference. That sign makes a big difference right there. All right. So let's go back to last night's.